Factoring by grouping. First, when you're factoring, you want to see if there's a common factor in all three terms of your trinomial. For example, in the expression 2x squared plus 10x plus 8, the expression can be written as 2 times the quantity x squared plus 5x plus 4. All that I did was I divided 2 out of each term and then put it on the outside by using the distributive property. Since the value of a, which is the coefficient of x squared, is now equal to 1, the equation can be factored by finding two numbers that multiply to get 4 and add to get 5. These numbers would be 4 and 1, so this expression can be written in factored form by saying 2 times the quantity x plus 4 times quantity x plus 1. With equations in the form ax squared plus bx plus c, where a is greater than 1, you can follow the procedure for factoring by grouping. Let's look at some examples. So the first thing I want to do is I want to multiply a by c, so that's this 2 by 7, and that'll give me 14. So I'm going to find factors of 14 that have a sum of 9. So if I'm listing factors of 14, I know 1 and 14 and 2 and 7. When I take the sum of 1 and 14, I get 15. When I take the sum of 2 and 7, I get 9. So 2 and 7 are the factors that I'm looking for, since they have a sum of 9. So what I'll do is I'm going to bring down the 2x squared, and then where this 9x is, instead of writing 9x, I'm going to split that up by saying plus 2x plus 7x. See, if I combined like terms, I'd get back to my 9x, but I'm wanting to break this down. Then I'll bring down my plus 7. Alright, the next step is going to be to split this in half. So I have two terms on one side of my black line I just drew and two terms on the other. So now for each half, I'm going to factor out my greatest common factor. So in this first half, 2x squared plus 2x, the biggest thing they both have in common is a 2, and they also have an x. So I'm going to write 2x, and when I divide 2x out of 2x squared, I have an x left over, and if I divide 2x out of 2x, I'm left with 1. Alright, so for the other half, the biggest thing that 7x and 7 have in common is 7. And if I divide 7 out of 7x, I'm left with x. And if I divide 7 out of 7, I'm left with 1. Now this is a good point to check to make sure you're on the right track. If what's inside these two parentheses is the same, then you know you're right. So from here, this is another step where we're using the distributive property. So just like before when we had the common factor and we pulled it out, here between this big term and this big term, they have a common factor and we're pulling that out. So what that leaves us with is, if we have the x plus 1 that we're pulling out, what's left is the 2x from the red and the 7 from the blue. So here we have our trinomial in factored form. Alright, now let's look at another example. Alright, so remember the first thing we want to do is see if there's something that can multiply into all three terms. In this case, there is. 3 goes into 9, 24, and 12. So I'm going to divide a 3 out. When I divide a 3 out of everything, that'll leave me with 3x squared plus 8x plus 4. So this is helpful because now our numbers are a little smaller. Alright, so I multiply a times c, so 3 times 4. So I'm going to find factors of 12 that have a sum of 8. So factors of 12, that's 1 and 12, but that sum is 13. And then 2 and 6, and that sum is 8. Oh, good. So I'm going to bring down the 3 in my big parentheses, and I'll bring down the 3x squared, and here I'm going to, instead of writing 8x, I'm going to write plus 2x plus 6x, and I'll bring down that plus 4. And here I'll split this in half. I'm still going to bring down the 3 and the big parentheses. So now I'll factor out greatest common factor of each side of my blue line. So between 3x squared and 2x, the biggest thing they have in common is just an x. When I divide x out of 3x squared, I'm left with 3x, and divide x out of 2x, I'm just left with 2. Alright, now if I divide the biggest thing, greatest common factor, out of 6x and 4 here, that would be 2. So positive 2. That leaves me with a 3x plus 2 on the inside. Alright, so now the last step, I'm going to bring down my 3 and I'm going to take this x plus 2 from the green and the red parts, and then I'll write my 3x plus 2, bringing that down. So the 3x plus 2 came from this. We knew we were going right because these were the same. And then what's on the outside of the parentheses come to its own set of parentheses, x and the 2, and then the 3 just gets carried down. Alright, let's look at number 3. Alright, for number 3, there's nothing that goes into all 3 terms, so we'll go ahead and multiply. 5 times 6 would give us 30, so we're finding factors of 30 that have a sum of negative 13. So factors of 30, 1 and 30 would make 31, 2 and 15 make 17, right? 3 and 10 make 13, and we want it to be negative 13, so we can do negative 3 and negative 10 to get negative 13. Okay, so we got 5x squared, and then that middle term I'm going to write as negative 3x minus 10x, and I'll bring down this plus 6, then I'll split this in half. When I'm looking at 5x squared and 3x, the largest thing they have in common is x, so that'll be 5x minus 3 inside the parentheses. When I look at this 10x squared, negative 10x squared plus 6, the largest thing that they have in common is we'll pull out a negative 2. Now I did a negative 2 because I want for this to be 5x minus 3 just like the other one. If I pulled out a positive 2, then it would be negative 5x plus 3. So since I want these to be the same, that's what I got to do. Alright, so we have the x from the blue and the purple 2, and then what's in the parentheses stays together. And we have our factored form. So let's go ahead to number 4. Alright, for number 4, nothing that goes into all 3 of those terms, so I'll go ahead and multiply 2 times negative 5. I get negative 10, so I'm finding factors of negative 10 that have a sum of positive 3. So factors of negative 10 be 1 and negative 10 makes negative 9, and 2 and negative 5 make negative 3, so then negative 2 and positive 5 would make a positive 3. So I'll bring down 2x squared, and I'll break this middle term up. And then split it in half. And the biggest thing that goes into 2x squared minus 2x would be 2x, which means leaves me with x minus 1 on the inside of the parentheses. Biggest thing that goes into 5x minus 5 is positive 5, which also leaves me with x minus 1. So remember, this last step works because of the distributive property. You're basically taking out the common factor of each term, which is x minus 1. And then you're left with the 2x from the red and the plus 5 from the green. So now we have this in factored form. Let's review the steps. First, look to see if there's a common factor in each term. Then, find two factors of AC that have a sum equal to b. Next, use those two factors to substitute an equivalent value in for bx. Then split the expression in half. Factor out the greatest common factor of each half by using the distributive property. Then also by using the distributive property, rewrite the expression in factored form by placing everything that's outside of each parentheses together in one set of parentheses to be one factor, and keeping everything that's inside the parentheses together to be the other factor. So now it's time to pause the video and complete the independent practice. Once you're done, press play to check your answers. And here are your answers to the independent practice.